Hi, everyone. Um, in the past several videos, you have seen how to use the law of sines when you have the ambiguous case. So remember that the ambiguous case happens when we have two sides and the non-included angle, SSA or ASS. And it's called ambiguous because we don't know if we have 0 triangles, 1 triangle, or 2 triangles. And in the case of having 2 triangles, we would have to solve 2 triangles, find all of the angles and sides of those 2 triangles. And in most of the videos, we've been seeing using the law of sines for ambiguous case. And I think it's a little bit confusing to set up and understand. And I think students sometimes just have a lot of trouble understanding how to figure out 0, 1, or 2 triangles, and then when there's 2, trying to solve both of those triangles. So my personal preference actually is to use the law of cosines. And I really couldn't find any videos out there that describe this method, so I had to make one. All right, so this example is actually the same example from the last video where they did use the law of sines. And truly, it is your choice which you end up using. All right, so I'm kind of labeling the triangle the same way their triangle was. And, you can maybe kind of tell if you set up the picture well like this that there could be 2 triangles because this 4 side looks like it would fit right in here. To truly be sure, we'd want to check the height, and the height would be, if it's less than 4, then it would there would be 2 triangles. And if it was greater than 4, then there'd be 0 triangles in this case. But we don't even have to worry about that if we use the law of cosines. All right, so the way we want to set up the law of cosines is to use the side and angle pair that we have. So we want to start with 4 squared and use that version of the law of cosines. So we'd have 4 squared equals, and then we could do c squared plus 5 squared minus 2 times c times 5 cosine of 48. Okay, use the 4 and then the 48 together. All right, so let's simplify this a little bit and see what we have. That's c squared. This is a c term, so that would be like minus 10 cos 48 all times c. And then our last term is 25. Okay, so what I'm seeing is a quadratic. Okay, and I have a c squared and a c and a constant term. So I am going to set my quadratic equal to 0. So that's 25 minus 16, which is 9. All right, and in order to solve this quadratic, I'm not going to try to factor that thing. I'm going to use the quadratic formula. So just to review the quad formula, we have x equals the opposite of b plus or minus the square root, b squared minus 4ac all over 2a. And you are going to want to rememorize this if you want to use this method, but it's not too bad. You'll use it a couple times and you'll remember it. All right, so in this case, unfortunately, our variable is c, so I'm still just going to use the a, b, and c here, and I'll just call our variable x during the problem. So we have an a of 1, that's the number in front of c of the variable squared term. We have a b of negative 10 cosine of 48 degrees, and we have a c of 9. All right, so let's use the quad formula. So we have x is equal to, and then, just apply the quad formula. So I recommend this 10 cosine 48 degrees. We type that into our calculator, and then we hit STO, store it, and then store it in B, okay, because that is the letter B. So you just hit alpha. So you'll type in 10 cosine of 48, hit enter, and then store is right above the on button, and then you'll do answer. It'll hit store, And then I like to just store it in the letter that it is. So you'd hit alpha and then the B, which is, in my calculator, it's yellow. Sometimes it's like an orange color. All right, so I've stored that in B. So instead of writing that out every time, I'm just going to write it as the capital B. Oh, and I think I should actually have made that a negative, right? Because B right here was negative. So I'm actually going to multiply that by a -1. So now my number is negative 6.69. Okay. And now I'm going to try to store that one again in alpha B. Okay. So I have to do the opposite of B. I'm going to use that capital B to show that that's the value I stored. Okay. Plus or minus the square root, and then I'll do B squared minus 4AC. Those I'll just use 1 and 9 for, all over 2A. All right, so I get negative. Actually, I'm just going to type it all in. So I'll do negative B. You just hit alpha and then the B to get that value. And then I'll do plus the square root of B squared, alpha B squared. And the good thing is that will then square the negative. So that'll end up being positive, minus 4 times 1 times 9. I like to hit enter there and then divide by the 2. So my first value, see if I can, there we go. My first value I got when I did negative b and then plus the square root was 4.82666, so 4.83. And then my second value, I'll do the same equation, but I will change it to minus the square root. I kind of just go back in my calculator and edit, and then I will divide that by 2, and I'll get 1.86. Okay, so what I want you to notice is my variable, which technically is actually side C, could be 4.83 or it could be 1.86. I got 2 positive side lengths. That means there's 2 triangles. Okay, and I already know side C for both of those triangles. So I'm 90% of the way there. What'll happen if there's one triangle, if there was one triangle, then one of these numbers would be positive and the other number would be negative. So you can't have a negative side length, and so you know that there's only one triangle. To have 0 triangles, what you'll end up getting is under the square root will end up being a negative, and your answer would be non-real. Okay, so if you get a non-real answer, that means 0 triangles. If you get 1 positive root for the quadratic formula, then you get 1 triangle. And if you get 2 positive roots of the quadratic, you get 2 triangles. So that's the case here. We got 2 triangles, and so now we do have to finish by solving both triangles. So what I'd want to do is kind of redraw the triangles so you know that this was 48 already, and then this triangle would be the 4.83 triangle, right? Because this side is longer. This is 4 and this is 5. And then all we have to do is find angle C and angle B. We can just use the law of sines for that because it's shorter. So I could do the sine of 48 divided by 4 is equal to the sine of B divided by 5. And then that means that the sine of B is equal to 5 times the sine of 48 divided by 4. Okay, just solving for sine of B. which that means that angle B is equal to the inverse sine of 5 sine 48 divided by 4. So if I type that in, I can do that all in one step. I got 68.27 degrees. So this angle would be 68.27. And then I would just subtract from 180 to get angle C. So for angle C, I do 180, take away 48, and take away the 68.27 that's still in my calculator. So for angle C, I got 63.73 degrees. Okay. These angles do match up with their sides, right? The smallest degree is opposite the smallest angle, and 68 is the largest, and it's opposite the 5. All right, so then we do have, this is case 1, triangle 1, I guess I should say, triangle 1. Okay, and then we do want to also draw triangle 2, and that triangle has, the third side is 1.86, so it actually looks a little different, right? That side, this side is still 4, 5, and 48 degrees, but side C is now 1.86. So this is an A, a C, and a B. All right, so we have all three sides and we have the one angle. I would just use the law of sines to find one of the other angles. So once again, I could do I guess I can't really do angle B right away, but I could do angle C. I guess angle B, I'd have to get, this is an obtuse angle, so I could get it from subtracting from 180 from this angle. But we're going to see how that works. So we'll do 48 and 4. We'll still stick with the givens. 48 and 4. And then that's going to be equal to, we'll do the sine of C divided by that 1.86. And then we'll just compare our answer at the end. So we have the sine of C would be 1.86 times the sine of 48, all divided by 4. So angle C is the inverse sine of 1.86 sine 48 divided by 4. So angle C is I got 20.22 degrees. So notice that it is a different triangle than the other triangle. 20.22. Okay, and then to find angle B, let's subtract from 180. So we'll do 180, take away 48, and our last answer. And I got 111.78. Okay, so I got a angle B right there is 111.78. Okay, now I want you to compare 68.27 and 111.78. You'll notice that if you added them together, you get 180 degrees, approximately. I actually think I rounded a little early in one of the steps right over here. So that's why it's a little tiny bit off. But that is the other way that you can get the other angle. So once you find 68.27, you could use this triangle, draw it out, and you just use 180 minus that to find this one. Okay. So hopefully that makes sense. It's just using the quadratic formula, and then you can just right away see how many triangles you have and Bonus, you get the side lengths from them.